Boom. All right, Clifford, I think this is recording.
May I have your attention, please?
Wait.
I just want to give a reminder on spring sports practice schedule today. For baseball, they will be right after school until 5 o'clock in the gym. And then tomorrow it'll be 5 to 7. That's for baseball. For varsity girls soccer, it is 3:30 to 5:30 at the elementary today. And tomorrow it'll be 3:15 to 5 in the gym. Thank you.
All right, Cliff, we're back after that announcement. You hopefully, hey, you guys got to be quiet. Quiet on the set, Falk. That was your cousin. All right. So, you remember this concept where we're adding up a whole bunch of rectangles to find the area under a curve, and it was simply the integral from a to b of f of x dx. Hopefully, you remember these concepts from geometry, where the area of a circle is pi r squared, which means the volume of a cylinder is pi r squared times the height. Let me write that in there. Height. There you go. All right. So what we're going to do now is we're going to take something like f of x equals square root of x, or y equals the square root of x, and rotate it around the x-axis. We're going to create a region here that's going to rotate around the x-axis. My class has trouble being quiet for you. I'm really trying to help you here, buddy. So I'm going to rotate that around the x-axis, and then I'm recording on something else, not on this. And then it's going to create like a bullet, a three-dimensional bullet-looking thing. We decided it would look like a bullet. So what it is, the reason you need to know those two previous concepts is because we're going to have all these like weightlifting plates stacked onto this as a barbell. So it's going to be little tiny ones, bigger, 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 bigger. So we're adding up an infinite number of plates. Well, each one of those cylindrical plates has a volume of pi r squared times the height. Now we turned it sideways, so the height is actually delta x. So we're taking this from way up here, pi r squared times height. It's pi r squared times delta x. The radius on each plate will be determined
Mr.
by...
Rainier, sir?
Yes?
If you get a chance, pop into our office if you get a chance.
Will do. So we're using root x as our height, squaring it because of the radius squared, got the pi. When we get to this next level, square root of x squared is just x. Pi we're going to pull out in front of the integral because we can. Integrate, we get 8 pi units cubed for the answer. 3 homework problems, Cliff. 3. You'll probably have to pause to get all this. Region bounded by these curves and these two axes, so this will be the integral from 1 to 3. Okay, revolved around the x-axis. They're all revolved around the x-axis. Region bounded by this semicircle. So the integral on this one would be negative 3 to 3. And don't forget the square, because it's radius squared on all of these. And then this last one, you're not going to get a number answer because it's going to be, we're deriving a formula. So it's going to be the integral from negative r to r. Again, this thing squared. I think you can pull this off. If you wanted to look, it's probably somewhere around section 7.2 in the book. So, miss you, buddy. Come back.